trigonometric functions, and modeling periodic functions. I'm going to just flip back a bit and talk about what a periodic function is again. If I want to describe this graph that I see in front of me, I want to look and see, does it have repeating behavior? Because that's what this unit's about. So I'm going to start where I can see something, and right here I see a 0, and I move upwards and back down, and I go up and I go down. And if I look to the right of that, I'm going to change the color here. I start on the same value, and I go up to exactly the same through the same y values, back down through the same y values, and up and down again, and the pattern repeats. And it appears that the pattern repeats. That's -1 it looks like, and that looks like -4.5. So minus 4.5 subtract -1 is -3.5. And if I look here, that looks like it's about 1.5. So 1.5 subtract, well, that looks like that was -1.5, so that's -3. And that's -1.5. And it looks like every 3 units, my pattern is repeating. So I'm repeating exactly the same y values at exactly the same intervals. So if I look here, and I count 3 over, 1, 2, 3, I find the same value. And if I'm here and I count 3 over, 1, 2, 3, I find the same value. So it would appear, oh, I was in the wrong spot. It would appear that it's a periodic function. The period is 3 units. If I want to find the amplitude, my maximum value is about 7. So my amplitude is 7, subtract my smallest value, which is 0, over 2. So my amplitude is about 3.5, and the equation of my axes is the max plus the min divided by 2. Oops, sorry. And of course, that's all written out really neatly here for you. Okay, and I used dots above when I was talking about the amplitude and the equation of the axis because it doesn't look quite like it goes up to 7, but it's pretty close. Okay, so we're going to look at an application of periodic functions, and we're going to think about a Ferris wheel, and we're going to talk about Mr. Alves and a ride on the Ferris wheel. And if I look at this, it says the Ferris wheel is 30 meters tall, and one rotation occurs every 40 seconds. So if I want to think of what's happening at each point on the graph, and we're talking about, sorry, I skipped over this, his height above the loading platform. So we're not going to think about how far it is compared to the ground. We're going to consider the loading platform where the bottom of the Ferris wheel is at exactly the same height as the platform. Now, if I think about this, at time 0 then, the height above the platform would be 0. And if it goes all the way around in 40 seconds, when it gets back to 40, it's going to be back to 0. And 40 seconds later, it's 80, and it's back to 0. And 40 seconds later, it's 120, and it's again back to 0. If it's going at a constant speed, halfway around, it should be at the top. And if the Ferris wheel is 30 meters tall, after 20 seconds, I should be 30 meters off the ground. And 20 seconds after that, 40 would be 60. And 20 seconds after the 80 would be 100. You'll notice that I go 20 seconds. If I add 40, oh, I'm at the same height every time I add 40. And here, every time I add 40, I'm at the same height. And that makes sense because the y values repeat every time for every cycle, sorry. And the length of the cycle here, the period of this is going to be 40, it would appear, because I keep doing the same thing. I'm repeating my motion. Now, this 20 seconds is at the halfway mark of the ride. But if I'm going at a constant speed, the quarter-way mark, halfway, right? I'd be at half that 30 meters, wouldn't I? I'd be at 15 meters after 10 seconds. And then again at 50, and again at 90. And then coming down on the Ferris wheel, halfway between the highest point and the lowest point, I would have to hit my halfway height again, wouldn't I? So at 30, 40 seconds later at 70, and 110 seconds later, I would be at 50 and again. So if I want to graph this, I've got 0, 0, 40, 0, 80, 0, and 120 and 0. After 20 seconds, I'm at my maximum height at 30. At 60 seconds, I'm back up there. And 100 seconds, I'm back up there again too. And at 10 seconds, I'm at my 15-meter mark. And at 30 and 50 and 70, or sorry, and 100, where? Sorry, I got off there a little bit. I'm missing some numbers here. At 10, at 30, at 50, not there. That is 70, sorry. I can't read the numbers, the lines. At 70, 80, at 90. All right, we're going to start this again because my numbers got off here. Let's erase this. Okay. All right, trying to read this, and I'm trying to do it quickly, and I need to be more careful. Same as I always tell you guys, be more careful. 0, maybe I should do it in order, and 10, and 15, and 20, and 30, and then I'm at 30 seconds, I'm back to 15, and 40 seconds, and I'm at 0. And at 50 seconds, I'm at 15, and 60 seconds, I'm at 30. At 70 seconds, I'm at 15, and 80 seconds, I'm back down to 0, and so on. And when I draw a smooth curve through all the lines, and of course, you're going to do a much better smooth curve than I'm doing here because I'm not even getting through all the points. Mobi is sometimes a little bit challenging to work with, and it's not a fabulous graph. But if it was drawn well, and of course, when you copy this into your notes, you're going to use graph paper, and you're going to be able to draw much smoother curves than I am because the pencil's easier to manipulate than a Mobi. And if you look at that, it looks somewhat like the graph we drew in class yesterday when we did going in circles. So what information can we get from this graph? We could realize that a ride on the Ferris wheel is periodic. Of course it is. We're doing the same thing over and over and over again. And each of these cycles on the graph is representing one rotation on the Ferris wheel. Everything repeats every 40 seconds. So my period is 40. And if I look at my amplitude, what is my amplitude? Remember, amplitude is the max minus the minimum divided by 2. So it's exactly 15. And the equation of the axes is the max plus the minimum divided by 2. So it's also y equals 15. How are these values related to the information we have up here? If they didn't tell us to draw the graph and create this table, could I have got any of this information or all of this information from what they told us in the first place? Absolutely. It makes one rotation every 40 seconds. So that's telling us how long it takes for the Ferris wheel to make one complete turn. So the period is 40 seconds. The Ferris wheel is 30 meters tall. Well, that was my maximum, and I compared my height to the distance above the platform, so the minimum is 0. So my amplitude was pretty straightforward. It was going to be half of the radius, or sorry, half of the diameter, because the Ferris wheel is 30 meters tall. It's representing the diameter, and the amplitude was just the radius. And it actually looks like the equation of the axes is also the radius. Will that always be true? Will I always be able to find my amplitude and the equation of my axes by knowing the diameter or radius? That's a question to think about over the next few days. And of course, I've got all of this information written here that you can copy out once you're done listening to the video lesson. Now, the last thing I want you to think about, if he continued to rotate, what's his height after 220 seconds? So what is h at 220? Notice I've highlighted the word height after 220 seconds, or more simply just h at 220. Well, this is it's a function, so I can use function notation. Let's go back to the graph. Oh, my graph doesn't go up to 220 seconds, and neither does my table. But I do know all my values from 0 to 120 seconds. And I also know that everything repeats every 40. So if I did h at 220 subtract 40, that's h at 180. Well, that's not in the data, I know. And it's not on my graph. I'm going to take 40 away again, and I'm left with 140. Still not on my graph. 140, take away 40, however, that takes me to 100. Let's see my graph again. At 100, I'm 30 meters. And if I look at the table, at 100, it's 30 meters. So if I know some of the values and I know the period, hopefully I can determine other values. And before class tomorrow, I'd like you to have a look or to complete exercise 1, page 2, number 1 and 2, and exercise 2, page 2, number 2.